Okay, so in the next couple lectures, I want to talk about translating and evaluating actual arguments. We've looked at passages so far, just a bunch of claims and done a lot of practice on how to translate them, right? We haven't yet looked at actual arguments. So I want to say a little bit about how we translate a whole argument into sort of symbolic form and how we evaluate arguments, right? And this thing of evaluating arguments, this is really where I think you start to see the point of symbolic logic, the point of doing this, right? Because once you translate an argument into symbolic form, there are some methods that will allow you to see whether it's valid or not. Look, you guys all probably, when you look at an argument, have some vague sense whether it's a good argument, whether it's a valid argument or not, right? Some vague spidey sense, does this work, right? But the whole point of logic is to go beyond that. We want to learn methods that allow us to clearly determine, is this valid or is it not? We know exactly if it's valid and why, or if it's not valid and why. So once we translate these arguments into symbolic form, I'm going to talk about a few different methods we can use to determine validity. First of these will just be the truth table method. We've already been doing a lot of truth tables, and this will work, right? We'll also talk about, at least in this lecture, some of the disadvantages of the truth table method. Disadvantage is it gets really, really long, really tedious, really fast, right? We'll talk about why that is. Next lecture, we'll talk about some valid forms of argument. And valid forms of argument, you can almost think about permitted moves, right? One way you can think about arguments is almost like, deductive arguments almost like a game, right? You have this conclusion. Can you get there from the stuff you're given? Well, valid forms of the argument are the moves we're allowed in the game, right? If you can get from your starting point to your end point, making only these, permitted moves, then it's a valid argument. If you can't, then it's not. That'll make a lot more sense as we get into them. One of the things you guys will see once we learn these valid forms of argument, it's going to save us a lot of work because we're not going to have to do this tedious truth table method, and we'll see exactly how and why the argument works if it does work. Okay, so let's move right along and start talking about translating whole arguments. So when we translate a whole argument, the key is to do it slowly and to break it into small pieces, right? Now, look, if you look at a whole long argument and try to just instantly translate it into some kind of symbolic form, that is a recipe for frustration. One of the things I want you guys to learn from logic, one of the important lessons of a class like this, is this sort of, almost you might say, analytical way of tackling a problem, right? Break it into very small pieces and take it step by step very slowly. That's the key to a lot of stuff in logic, and it's the key to translating whole arguments. Do it slowly, go step by step. Don't bite off more than you can chew, you might say. Okay, so let me give you guys an example of how that's going to work. So one thing we've got here, you have to ask yourself, how many distinct claims does the argument discuss? How many things does it talk about, right? And for each of those distinct claims, give that claim a letter. For each of the things the argument talks about, put out that claim, give it a letter, this equals this particular claim. All right, how does that work? Well, let's take a simple argument, right? Here is an example of a pretty simple argument. This uses only the logical connectives we've looked at so far, and, we can put it in symbolic form using those. Either Jane or Mary will get an A in logic, right? Let's assume that, for some reason, I mean, I don't do this, but let's say the class is super hard, there's a curve, these two are the best students, they're fighting it out, right? Mary won't get an A in both logic or anatomy. The argument just says that, but, imagine, well, Mary, she can either work really hard in one class or the other, she puts time in anatomy, she's not going to get an A in logic, right? So she'll get an A in anatomy. She's going to put the effort in her anatomy class. So she won't get the A in logic, so Jane will be the one who gets the A, right? All right. So, as you might be able to tell or might not, this is a valid argument, but we want to see why, right? So first step, let's think about the different claims in the argument, the different distinct facts that it talks about. And when you think about it, it puts them together in different ways, but there are 3 different things the argument talks about. Jane getting an A in logic, Mary getting an A in logic, and Mary getting an A in anatomy, right? So that gives us the 3 letters we need to use. P, Jane will get an A in logic, right? Q, Mary will get an A in logic. R, Mary will get an A in anatomy. So we've got the 3 letters we're going to need to use. Those are the 3 different things the argument talks about. Now that we've got the letters for those claims, we can move on, translate the next step, the different ways, the different claims it makes about these statements. So next step, do what you've done before. Just write out the argument in this sort of distilled step-by-step form, right? 1, 2, 3, 4, 5 to get your conclusion. Either Jane or Mary will get an A in logic. 1, Mary won't get an A in both logic and anatomy. 2, 3, Mary will get an A in anatomy. R, therefore Mary won't get an A in logic. This is a sort of sub-argument, right? 5, so Jane will get an A in logic. Well, now look, once we have these statements and once we have, our letters letting us know what what letters represent each claim, well, we can go and we can plug in, for each of these statements, we can plug in just formulas with our logical connectives, right? Either Jane or Mary will get an A in logic, P or Q. Mary won't get an A in both logic and anatomy, not Q and R. She's not going to get an A in both, so not Q and R, right? Very important to put this not symbol outside the parentheses. Mary will get an A in anatomy, well, that's R. Therefore, Mary won't get an A in logic. Q is Mary will get an A in logic, so we get not Q here. Our conclusion, so Jane will get an A in logic equals P, right? So hopefully you guys understand, each step here, how this is going so far, right? So now that we've got this, we can just get rid of all the words. We can just look at the form of the argument. And remember, here's the form of argument. P or Q, not Q and R, not Q, so P. And so remember, validity is all about the form of an argument. And that's actually one of the advantages of this sort of symbolic way of representing it. We can just completely push aside for the time being the content of the argument and think about the form, right? We don't need to think about what it says. We just look at the form, how the pieces hang together, right? All right. So is this a valid argument or not? You guys probably know I said, well, yeah, it is. Well, how do we know it's a valid argument? Well, one way we can determine whether it's a valid argument is to use a truth table, right? Remember our definition of validity. Validity means that in every case where all the premises are true, the conclusion is true as well. So let's look at our truth table. look, here's the example of the truth table. I'm not, writing out, true and false here, just TTFF, right? So we write out the truth table. First, we put in our 3 different letters, right? Then we want to make sure we have every possible combination, right? So the way you do this, so for P, you put half true, half false. For Q, true, true, false, false, true, true, false, false. Basically, for Q, you've got 8, lines. You'll do 1/4 of each and then switch, right? 2 trues, 2 falses, 2 trues, 2 falses, right, to reach the end. I'll talk a little bit about the method here. You don't really need to know that because we are not, you can do truth tables for as many letters as you want. For reasons I'll talk about, we're not going to do them with more than 3, right? So for R, you just do true, false, true, false, true, false. For this one, it's like 1/8 with each one and then the next. There are 8 lines. So that's 1, then switch, 1, then switch, right? All right. So now we've got our 3 different letters. So then we go to the different statements, right? So, we can go through here. First line, well, P or Q is true. Q and R is false because it says, not Q and R is false because it says, well, one of these, not both of them, and they're both true here, so this is false. Not Q is false, right? You can just keep going down the line here, right? You fill in with these, you've got the whole table. Well, so how do we know if our argument is valid? Well, remember the 3 premises in our argument. R, P or Q, not Q and R, and not Q. Is there any line of the truth table where our 4 premises are true, where P is false? If there's no line, if there's no combination where R, P or Q, not Q and R, and not Q is true and P is false, then it's a valid argument. Well, is it or not, right? Well, it is, right? There's only one possible line of the argument where all of our premises are true, right? Every other line, at least one of our premises is false. And the one line where all of our premises are true, P happens to be true as well, right? So there's no way we can imagine all of our premises being true and P being false, right? The one possible case here where every single one of these premises is true, P is also true. This third line, R is true, P or Q is true, not Q and R is true, and not Q is true, right? P is also true. Only possibility where all the premises are true and P is true as well, right? So when you do this truth table method, just look at every possible line where the premises are true and then look at the letter that's the conclusion and see if it's true as well, right? If on every single line where the premises are true, the conclusion's true as well, then it's a valid argument. So let's go with one more example of this. This is a valid argument. Let's take an invalid argument and use the truth table method to show that it's invalid. I think this will be useful as well. So here's another argument. Either sales will go up and the boss will be happy, or expenses will go up and the boss will not be happy. Therefore, sales and expenses will not both go up. All right, so let's go through the whole process. Again, I'm going to move a little faster in this one, just because we've already done this. But so there's 3 different facts to talk about. Sales going up, expenses going up, and whether or not the boss is happy, right? So our first step is, we take these 3 facts. S equals sales will go up, E equals expenses will go up, B equals the boss will be happy, right? So we've got these 3. So then we think about, well, how do we distill this argument? How do we put it in this premise, however many premises, conclusion form? Well, turns out to be pretty simple here, despite there being a lot going on, right? There's one premise: either sales will go up and the boss will be happy, or expenses will go up and the boss will not be happy. All right, so how do we symbolize that? S and B, sales will go up and the boss will be happy, or E and not B, expenses will go up and the boss won't be happy. Conclusion, therefore, sales and expenses will not both go up. Now you guys can probably already see this isn't a valid argument, but let's do the truth table method. It'll show us exactly where and how it's not valid, exactly where and how these premises can be true and conclusion false. So we see, well, obviously it's not a valid argument because you got your premise, and in two cases where the premise is true, the very first two on the truth table, our conclusion is false. If, sales goes up, expenses goes up, and the boss is happy, well, then our premise is true and our conclusion is false. If sales go up, expenses go up, and the boss is unhappy, well, again, premise true, conclusion false. Premise is saying sales and expenses won't go up. That's exactly the possibility here, right? So we can already just see first two lines here, premise true, conclusion false. This is not a valid argument. Okay, so 2 points. One is that the truth table can often be useful. Look, the argument this simple, you might not need a truth table to untangle why it's invalid, but sometimes rather than just trying to break your head and be like, okay, can I imagine a way this is false? Premise is true, conclusion false. You can just sketch this truth table and it'll show you exactly how without having to go to all that trouble of imagining, right? And look, I think sometimes when people take logic, they get the impression that truth tables are a sort of training wheels or a kiddie way, a simple way that we're going to go past to solve problems or to see if something's valid. That's not always true. This can be a very useful tool even for more advanced problems. I was sort of really, I have an advanced logic book I'm kind of going through just to bone up on the stuff for the class. And I was trying to do a problem, and I tried all this complicated stuff to solve it. I get very frustrated. I look in the answer key, right? We all do that at some point. And the answer key is like, well, here's the easiest way to solve it, and it was just a truth table, right? So keep this truth table method in mind as a tool. It will sometimes be useful. Even for advanced stuff, there's a reason to learn it. It does have its limitations, though, right? And the limitation is this. When you have a lot of letters, when you have a lot of different statements, the truth table gets really long, really boring to write, and hard to follow very, very quickly, right? Remember, I said, well, basically, how many lines do you need for a truth table? Well, it's 2 to the power of however many letters you need, right? You guys don't need to do the math. If you can, do it. Just the upshot of this is it doubles every time you add a new letter, right? So if we had 4 letters here, well, then we'd have 16 lines. Or sorry, if we had 4, 32, you can see how hard this gets to deal with very, very quickly. So I'm not really going to use truth tables for anything for more than 3 letters, just because if it's got more than that, there's usually easier, better ways to test for validity. So that's what we're going to start doing next lecture when we start talking about these valid forms of argument. Remember, so we can think of this kind of like a game. Well, these are the moves you're allowed to make.